Alright, we want to calculate the concentration of hydronium for a 1.01 times 10 to the negative 2 molarity concentration of KOH solution. So the first step would be to calculate the pOH based on this concentration of KOH, and we know this because KOH is a base. It has OH that it gives to a solution, so it's easier to calculate pOH of the solution than to calculate pH. Then we can use the pOH to calculate the pH because pH is just 14 minus pOH. And third, we can use that pH in this formula, negative log of concentration of hydronium, to isolate the concentration of hydronium after plugging in whatever we get from the step 2 into pH here. Alright, so to calculate the pOH, first make sure you understand that potassium is just a spectator ion, similar to Na plus or lithium, so we can ignore them in our calculations. They don't affect the concentrations of hydrogen ions or OH ions at all. So we can say that the concentration of OH minus equals this number, 1.10 times 10 to the negative 2 molarity. And in case you don't know, molarity is the same as moles over liters. Alright, and then pOH is calculated using a formula super similar to this one, except instead of hydronium concentration, we use OH minus concentration. So we would plug in 1.10 times 10 to the negative 2 molarity, and we get about 1.959, which we will round to 3 significant figures based on the concentration to get 1.96. Alright, cool. So with this pOH of 1.96, we can calculate the pH, which would be 14 minus 1.96, which is 12.04. And then we can plug in this pH into this equation. So we'll say 12.04 equals negative log of concentration of hydronium. Now, the easiest way to get rid of this log is to set both sides as an exponent with base 10. But before we do that, we want to get rid of this negative sign to make the calculations a bit easier. So let's do that by multiplying each side by negative 1. So now we have negative 12.04 equals log of concentration of hydronium. Now we can set both sides as exponents with base 10, and we get 10 to the negative 12.04 is equal to, these cancel out, the concentration of hydronium, and when you calculate this out, you get 9.12 times 10 to the negative 13 molarity. So this is the number of moles of hydronium per liter of this KOH solution. Thanks for watching.